Easy BTech, your guide for BTech and beyond. In the channel, you can learn the subject very easily. My name is G. Sampath. I am going to explain the subject VLSI design. Today, we are going to discuss about the standard cells and FPGAs. Okay, so what is standard cell and what is FPGA? Right, before going to know the FPGA, let us see the standard cells. Standard cells. Okay, so what is standard cell? Standard cell is a predefined functions, predefined cells in a circuit. It is a predefined it is predefined logic elements, predefined logic elements, predefined logic elements in a circuit. Okay, so it is a predefined logic elements in a circuit. Okay, used in, so what is used for the standard cells? Standard cells are stored. Okay, standard cells store the data, and perform specific functions okay, specific functions like and or inverters. So inverter function, AND function, okay, NAND function, so on. Okay, a specific it is a predefined logic elements. It is stored data and perform specific functions, AND or NAND. Okay, so let us see this one. Okay, so let us see this levels of abstraction of a chip. Then we go for the FPGA. Okay, so it is a chip level, and second one is module level, and this is a cell based design, and this is for transistor level representation. Okay, so the first one is so this is a chip level. We can use this chip level. Okay, this is a chip level, and this one is module level. So this is module level representation. This is a module level representation. Module level. Okay, module level. And here this is a cell based design. NOT gate, AND gates, NOT gate, AND gate, OR gate, OR gates, and flip flops. Specific functions and storage data. Okay, and below this is a transistor level representation. So transistors, you can use diodes, transistor diode, resistance, and capacitance. So this one is a transistor level. So this is a level of abstraction. level of abstraction. So different levels. So this the bottom level is a transistor level, chip designing. So it is a transistor level. Okay, this is a bottom level is transistor level. Second one, this is a cell based. Okay, it is a cell based design. Okay, cell based storage cell. Okay, we call it is or storage cell or storage cell. So it is a module and chip level. Okay, module and chip level. Okay, so cell based or standard cells, specific functions. Okay, specific functions, implement the specific functions, and also it is a storage device. So flip flops are used, flip flops and logic gates, flip flops and logic gates. Okay, so cell based design is for a predefined elements in the circuit, storage data, store the data, perform a specific functions. So and okay, inverters and NAND and flip flops are used. Flip flops are used for store the data. Flip flops are used. Flip flops used in cell based design. Used in cell design. Okay, in cell design. Cell design for store the data. Store the data. For store the data, flip flops are used. Flip flops are used. Temporary stores the data. Okay. Now let us see the FPGAs. So what is FPGA? Okay, FPGA, field programmable FPGA. FPGA is a field programmable gate array. Okay, so field programmable gate array. Field programmable gate array. Okay, field programmable gate array. So it is a complex design. It is a complex design. Millions of gates. Okay, it is complex design. It is more complex design. More complex design. More complex design. Okay, because millions of logic gate, millions of logic blocks, millions of logic blocks, millions of logic blocks, millions of logic blocks. Okay, millions of logic blocks. Let us see what is the logic blocks here. So basic logic block. So basic logic block is basic logic block used in this is lookup tables. Okay, lookup tables. Okay, so lookup tables which store 1 bit data. Okay, which store 1 bit data. So it is a more complex design. Billions of logic blocks are there. So basic logic blocks used in FPGA, lookup tables. So lookup tables which stores the 1 bit data. Right. So more cost. So more cost. Cost is high. Okay, cost is high. Cost is high, and also more power consumption. More power consumption. So it is, we can say it is a difference between FPGA and CPLD. So more cost, CPLD low cost. So more logic blocks, less logic blocks, right? More power consumption. More power consumption in FPGA. Okay, so cost is high, and it is a RAM based design. It is RAM based design. RAM based design. Okay, RAM based design. So what is the RAM based design? When power off, lost the data. when power off, when power off, so it lost the data. Okay, so it lost the data, it lost the data, it lost the stored data. Okay, so it is a RAM based design, it is a RAM based design, whereas CPLD EPRAM, electrically ROM based design, it is a ROM based design CPLD, and it is a RAM based design, so more power consumption, so cost is high, right? So basic logic blocks are designed by lookup tables, lookup tables. So let us see this one. Before going to design this FPGA, let us see the lookup table. Okay, lookup table. Lookup tables. Okay, so lookup table, it is designed by, okay, multiplexer, flip flops. Okay, multiplexers and storage data. So let us see this one. Let us see this one. It is a multiplexer. It is a multiplexer. It is a two input lookup table. Okay, two input lookup table circuit. Okay, two input lookup table circuit. Two input lookup table circuit. Okay, two input lookup table circuits. Here X1 is the input, and X2 is also inputs. X2 is also input. Okay, here you can see this is X1 and X2, and output is a functional output. Output is a functional output. So this is F is a functional output. Okay, so the data stored here, okay, data stored here maybe 0 or 1, 0 or 1. The data stored here, it will be 0 or 1. Data stored here, it will be 0 or 1. 0 or 1. Okay, so here 0 or 1, 0 or 1. Maybe stored 0 or 1, stored 0 or 1. Okay, so these are the, so circuit A represents, circuit A, it is a two input circuit lookup table, two input circuit lookup table, two input circuit lookup table. Okay, two input circuit lookup table. X1, X2 are the input. F is a functional output. F is a functional output. Okay, F is a functional output. So let us take this one. Let us take the function. The functional truth table is, the functional truth table is X1 and X2. X1 and X2. 0, 0, 0, 1, 1, 0 and 1, 1. Okay, then the functional output is, the functional output is 1, 0, 0 and 1. So it is a truth table. So truth table, truth table. Okay, truth table of the two input circuit, truth table of two input circuit, two input circuit, two input circuit. Okay, two input circuit. So let us design the truth table circuit here. Let us design the truth table circuit. So according to the inputs X and X1 and X2, okay, then it stores the data, then it stores the data. Okay, then the functional output will be taken, the functional output will be taken. Okay, so according to the inputs X1, this is X1 and X2, according to the X1 and X2, okay, the functional output will be taken. These are the muxes stored the 1 bit data. Okay, store the 1 bit data. So we can see this one. So according to the table, okay, according to the table, now what is the data stored x1 and this is x2, x1 and x2, this is functional output. So according to the data, so when x1 x2 0 0, what is the functional output is stored here? It is 1 0 0 and 1. Okay, so x1 x2 is equal to 0 0, this is 0 and 0, then functional output will be f1 is equal to 1. Okay, so x1 x2 0 0, functional output will be 1 will be taken. Okay, when 0 1, then 0 will be taken. So it will be 0 or 1, so it will be taken 1 for 0 0 0 1, 0 will be taken. Okay, so 1 0, it will be 0 will be taken, 1 1, it will be 1 taken. So according to the truth table, the lookup table design, so this is figure C. So lookup table design, okay, lookup table design, okay, lookup table design, that the truth table design, lookup table design, the truth table, 2 input 2 table, okay, design 2 input 2 table, okay, truth table. According to the truth table, so it will be designed, so it will be taken x1 0 0, only 1 will be taken, so this is a mux. Okay, this is a mux, it is a 2 input mux, 2 input maxima. Okay, this is also mux representation, mux. Okay, mux representation, it will be select, according to that it will be taken this one or this one. Okay, so it will be selection, x1 is equal to 0, x2 is equal to 0, so it will be taken 0 or 1, 0 or 1, 0 or 1. So the lookup total, it is called as a lookup table, so it stores, it will be stores 0 or 1, it will be stores 0 or 1. So according to the truth table, then it will be taken the final output, taken the output. So 1 will be taken, so 1 will be designed, so it will be designed by the 1 0 0 and 1 will be stored as a functional output, as a functional output. Okay, so let us take the 3 input, let us take the 3 input. Okay, 3 input summing, right, 3 input adder, 3 input adder sum value. Let us design 3 input sum adder. Okay, only let us take the sum value. Okay, 1 2 3 4 5 and 6. Okay, from here to one more mux is taken, one more mux is taken, and from here it will be taken one more multiplexer. Okay, from here will be taken the final multiplexer. So it will be designed by according to the truth table. Okay, so the inputs are, so this is input A. Okay, now input B, which is connected over here, input B connected over here. Now input C is connected, selection of the first one, first level. Okay, now these are the data sum. Okay, data stored sum value. Okay, data stored sum value, bits over here. Okay, now so let us see the inputs are A, B and C. Now the final output, so ABC inputs are here, 3 inputs, 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 1 0 and 1 1 1. Let us take the adding sum value. Okay, it is a sum value design function. So 0 0 0 it will be 0. Let us carry will be 0. So some value 1 carry value 0. Some value 1 carry value 0. So it will be 0 and 1. Now it will be 1 and 0. It will be 0 and 1. Now it will be 1 and 1. So inputs and outputs. Inputs and outputs. So output is some value. Output is some value. Output is some value. If is a some value. So some value output is taken. It will be stored in the multiplexers. Inputs are. So what is the some value here? 3 input 0 0 0. First it will be taken 0. Okay, 0. And then it will be 0 0 1. It will be 1. Okay, now it will be 1 0. This some value. The some value will be stored here. Okay. So 0 1 1 0 1 and 0 1 0 0 1 1 1 0 0 1 0 1. Let me take this is 1 0 0. Now 1 0 1 1 0 1 1 1 0 and 1 1 1. Okay. Now what happens here? 1 0 0 it will 1 0. So it will be 0 and 1. Okay. Again this will be 0 and 1. It will be 1 and 1. Okay. Now what happens here? Now 1 1 0 and 1 0 0 and 1. Okay. So the three inputs are A, B, C inputs. So the stored bit will be taken 0 0 0 and this first bit will be as a output, some value output, and 0 0 1 according to the inputs. Then the sum output will be taken. The selection of the mux, selection of inputs are given to the multiplexers. Okay, given to the multiplexer. The data output will be taken. The data output will be taken. Okay, data output will be taken. So it is D. Fourth one, 3 input lookup table. It is a 3 input lookup table. Okay, 3 input lookup table, sum output. Okay, sum output. Sum output. So sum output bit will taken the stored bit over here. So according to the inputs, the data will be stored bit data will be taken as a output. Taken as a output. Okay, taken as a output. Now let us take this one in lookup table and flip flops. Okay, so let us take this lookup table. Let us take this lookup table. Output of this one is given to the D flip flop, and finally it will be connected to one multiplexer after storing. Okay, and this may be connected over here. We are given to the clock signal and a 3 input lookup table. So it is 3 input lookup table. Okay, these are the inputs, and let us take the sum value is given to this D flip flop according to the clock signal and by selection. Okay, selection. So selection of stored bit data directly will be taken. Let us F is a selection. Then final output. Let us take this is a final output. Final output. So figure F. Okay. Let us say figure E. It is representation of lookup table. Okay. Lookup table 3 inputs. Lookup table 3 input. Lookup table 3 input. D flip flop. D flip flop and 2 by 1 multiplexer. Okay, 2 by 1 multiplexer. 2 by 1 multiplexer design. So lookup table internally it will design by stored bit data. Okay, according to the input, then lookup tables are stored the bit data, only 1 bit data. Then output is some value. Okay, output is some value which is given to the flip flop, D flip flop. If you want to store the data, then same data will be connected over here. And if not directly connected to this one, so directly sometimes it will be stored. So according to the clock signal, then it will be stored and it will be given to the multiplexer. So according to the selection of this multiplexer, the output will be taken stored bit data or directly from the or directly from this lookup table. Okay, so lookup tables are stores contains the stored data. Okay, stores data. So according to the input selection, the data bit will be processed. According to the input data, the data bit will be processed. The stored bit data. Okay, so it will be stored 0 or 1. So it will be designed this truth table. Okay, if I want to design the lookup tables, multiplexers, and stores the 0 or 1 bit data. So it stores 1 bit data according to the 2 input data. So how many bit it stores here? 1, 0, 0 and 1. So 1, 0, 0, 1 is stored according to this input data. Then the data output will be taken. So 1 is taken for 0, 0. Then second one is taken for 0, 1. 1, 0, 0 will be taken. 1, 1, 1 will be taken. Okay. Selection by the multiplexers. Multiplexers is selection by the inputs. Okay. So the multiplexers are selection by this A, B, C. So the data stored bit will be taken. So what is the data stored bit will be taken? Some value is a data stored bit which will be taken as a output. So here also lookup table output. Okay, lookup table output according to the input which stores in D flip-flop, and multiplexer selection output will be taken. So the mostly used standard cell is lookup table. So let us see the general structure of this FPGA. Okay, so it will be connected IO pads. Okay, top, bottom, left side and right side, and the internally and in between it is connected to the logic blocks. These are the logic blocks. Okay, these are the logic blocks. Okay, these are the logic blocks. So each logic block consists of lookup tables. Okay, lookup tables. Just now we are seeing. So whatever may be the functional specific function, we can design. Okay, and flip-flops also connected. Okay, so some programmable interconnections. So programmable interconnections. We are using this programmable interconnections. These are the programmable interconnections in between the logic blocks. Programmable interconnections. Okay, programmable interconnections. These are the programmable interconnections. Programmable interconnection between input and the logic blocks. Okay, so these are the programmable interconnections. Programmable switches, programmable switch connections. Okay, we can write the code in a computer. Okay, and we can dump this into this FPGA. Okay, verify this. Verify this in FPGA. Okay, verify by using FPGA. So FPGA designed by logic blocks. The program will be dumped into this FPGA. Verification of that particular program. Okay, FPGA is a programmable design, field programmable design. Verification of that program by using FPGA kit. It is FPGA kit, Altera and Xilinx. Okay, so these are the IO pads. These are the IO pads, input output pads. We can dump into this IO pads. Okay, these are the IO pads. And programmable interconnection from here, one logic block to another logic block. Programmable interconnections. Okay, so this represents this is a logic block. logic block. Okay, logic block. And the small one represent, this is a programmable interconnection. Programmable interconnection. Okay, programmable interconnection. Interconnection. Okay, programmable interconnections. So these are the IO connection, IO pads. Okay, IO connections. You can say this is IO pads, IO pad connections, input output connections, IO connections. Okay, this is a general structure of FPGA. FPGA general structure. General structure. Okay, general structure. So input output pad connections, logic blocks. Each logic block consists the lookup table. Each logic block consists the lookup table. So each logic block consists the lookup tables. Okay, so it is a lookup tables. So this is a programmable interconnection. So one logic block to another logic block. If one logic block completed, it goes to the second logic block. So first rows completed. Okay, second row, third row, so on. It will be millions of logic blocks design. Each logic block lookup tables. Okay, so we can implement any specific functions. All the logic gates, multiplexer, demultiplexer, all the programs which we can write a code in a system that will be dumped into this FPGA and verify the functionality. Okay, so this is about standard cells and FPGA. Okay, thank you. Please subscribe our channel, like and inform to your friends. Thank you.